Hello everyone. So today we're going to learn about Modulo Basic or Modulo Introduction here. So we're going to start it with the definition. So what is Modulo? So you can read it here that Modulo is the mathematical operation that gives the remainder. So in Modulo, we only care about the remainder. So for example, if we want to divide it 13, divide it by 5, we want to know what is the remainder. So for that, we can use this first expression. So when 13 divided by 5, the remainder is 3. So hence we write it down as 13. We can use this function modulo, or we just write it as mod 5 equals to 3. So this is the first expressions of modulo. The second one here is that we're going to use this symbol here. It's not equals, but it's more we call it equivalent. So what is equivalent? So equivalent is actually you combine two equations of modulo. So the first one is 13 equals to 13 modulo 5 will be equals to 3. And then the second one, we're using this basic number 3. And then we modulo it again with 5, and the result of course will be 3. So then we can combine these two. We can just write them as 13 then will be equivalent to 3 modulo 5, right? So if we can read this one correctly, it will become 13 modulo 5 will be equivalent to 3 modulo 5 because both of them got result 3. So that's the first one about the definitions of modulo with these two expressions. So sometimes we're using this simple expression, right? We're using equal sign, and then the other times as well we can use this equivalent. So for modulo, sometimes we can express modulo like this one, 3 modulo 5. Sorry, I will change it, not 3, but let's say 2 modulo 5 will be equals to 2, right? So this is the normal way to express modulo, as we already learned before, but sometimes we need the negative number. So instead of writing 2 as the result, instead we're using the one that is log, which is minus 3. So 2 modulo 5, instead of using 2, I will using minus 3 because 2 is actually need another 3 in order to reach 5. Another example, so to make the concept clear, for example, 8 modulo 9, I can write it as just 8, right? Or if I want to use the negative value, I can use minus 1 because 8 actually need another number 1 in order to reach 9. So this is negative expressions of modulo, and we can see in the later discussion why we need this negative, or sometimes we need negative expression to solve modulo problems. So next one is that how to calculate modulo, or the basic property of modulo. So the first one here is additive properties. Additive property, so you can see here this one is the additive, so a plus b modulo n. You can break down them as a modulo n here, and then the next one is b modulo n, the second term here, and then if a modulo n and b modulo n still bigger than n, then we can express another modulo. And we can continue to adding modulo n until the result is less than n. So for example, let's say this one, 14 plus 8 modulo 5. So if we are using the additive properties, so 14 modulo 5 is 4 plus 8 modulo 5 is 3. And then 4 plus 3 is 7 or still bigger than 5. Then we will apply another modulo 5 until we reach our goal, which is less than 5, or in this case 2. So that's the additive properties. So if we combine them, like we can calculate them normally, 14 plus 8 is 22. And if you calculate 22 modulo 5, we will get 2 as the result. So same with this one, but this one we're using in order to explain these additive properties. The second properties here is the multiplicative property, which is same thing, right? With the previous one, the difference now is the sign is multiplication. So same thing here. 7 modulo 5 is 2 multiplied by 8 modulo 5 is 3. So since 2 times 3 is 6, then we will apply another modulo 5. Then we will get the result 1. Same thing if I calculate them directly. 7 plus 8 modulo 5. So 7 plus 8 is 56. And then 56 modulo 5 is 1. So same thing, same result. The next one, the power of or exponential properties. So this one is a more complicated one. So here we have here two ways on how to calculate them. The first one is a general ways to solve it, and then the second one is that when we face with counting the last digits, the last two digits, and etc. So the first one is the general one. So for example, here we have a problem. Find the remainder of 17 power of 50 when divided by 5. So what we can apply here is first step is simplify the base number. So for simplifying the base number, we can use the multiplicative property. So for example, here we have 17 power of 50. So it means the 17 times 17 times 17 until the 50th one modulo 5. But if we are using the multiplicative, it means that I can operate each of this number with modulo 5. So here I will using 17 modulo 5 is 2 times another 17 modulo 5 is 2, and so on until the 50th one. And then if we count the result, we will get 2 power of 50 modulo 5. So with this one, you can see that we already simplify the base number. Or if we calculate it this one, we can just simply say that 17 power of 50 modulo 5 is 17 modulo 5, which is 2. The power still the same, modulo 5. Okay, so by simplifying the base number, now we can calculate things more easier because the number is more smaller. The second one is now the second step, find the power pattern. So the power pattern here is that, so now we want to calculate this 2 power of 50 modulo 5. So the power pattern. So the power pattern is the power pattern of this number here, 2. So we can calculate them one by one. 2 modulo 5 is 2. 2 power of 2 modulo 5 is 4. 2 power of 3 modulo 5 is 3. 2 power of 4 modulo 5 is 1. So after we got 1, if we continue again, then it will be repeat, right? It will repeat the first one. So it means that this is the full cycle of the power pattern of 2. So with that, now we can continue to calculate it. So 2 power of 50 modulo 5, we can write it as, or we can change this 50 as 2 power of 4 times 12 plus 2 modulo 5. So again, continue. So it means that 2 power of 4 power of 12 times 2 power of 2 modulo 5. Right, so from here you can see that we already solved this one, 2 power of 4 modulo 5. So we will apply this modulo 5, or we will operate it one by one. So I will continue it here, and I will write it again. 2 power of 4 power of 12 times 2 power of 2 modulo 5. So here you can see that I will, as we did before in step 1, simplifying this base number. So 2 power of 4 modulo 5 is actually 1. So then we will get 1 power of 12 times 2 power of 2 is 4 modulo 5. So 1 power of 12 is 1. 1 times 4 is 4. Then the answer is 4. So this is the general ways on how to solve the power of or exponential modulo. Now the second one, when we are asking, or not the second one, still the first one, but now the power pattern, we will try to find the one that will result in 1 or minus 1 as remainder. So as you can see here, that find the power pattern, we will rely on this pattern here. And then the pattern will always end with 1. But for the second one, we not only rely on 1, but we can using minus 1 as well. So same thing, same problem. So we already know that 17 power of 50 modulo 5 will result in 4 as remainder. But let's say for this one, I will using minus 1. Okay, so we're using the same step. First step is that we will simplify. So 17 power of 50 modulo 5 is 2 power of 50 modulo 5. And then after that, I will take 2, factor 2 from 50. So then I will get 2 power of 2 power of 25 modulo 5. Why? Because 2 power of 2 is actually 4. So 4 power of 25 modulo 5. So now 4, if I modulo with 5, the result is -1. Right, so we will get -1 power of 25 modulo 5. So -1 power 25 is -1. And then -1 modulo 5 is 4. Now, if you are asking about, so why -1 modulo 5 is 4? So the number here is always the additions of 5. So for example, if I say that -1 modulo 5 is equals to 4, then every time I add 5 here, the result will always the same. So for example, if I add 5, so if I add 5, this one will become 4. 4 modulo 5 is same thing 4. Again, if I add another 5, modulo 5, same thing, the result is 4. So this is the reason why -1 modulo 5 is equals to 4. So okay, so this is the general one, or the general ways how to solve exponential modulo. The next one is the last digit, last two digits, etc. So you can see here that the questions is find the last digit of 17 power of 50, and they do not ask about when it divided by what number. They just asking about the last digit. So from there we will using modulo 10 to solve this one. Why modulo 10? Because for modulo 10, the result will become, or the possible result is 0, 9, 2, and so on until 9. So this is the number that will represent the last digit. So that's why we're using modulo 10. So we will write it down 17 power of 50 modulo 10, and we can simplify this one as previous, becomes 7 power of 50 modulo 10. Same thing, right? We will simplify the 17 with modulo 10. So the result is 7 power of 50 modulo 10. Now from here, we can use pattern. So 7 modulo 10 is 7. 7 power of 2, which is 49. Modulo 10 is 9. But instead of 9, because you can see here 9 is just one different with 10, I will write it down not 9. Instead, I will using -1 instead of prolong the pattern, right? So I will just stop here -1. So the conclusion is 7 power of 2 modulo 10 will be equals to -1, and then we will using it. So 7 power of 2, it means that I will change this one. 7 power of 50 becomes 7 power of 2, and then power of 25 modulo 10. So 7 power of 2 modulo 10 is -1 power of 25 modulo 10. -1 power of 25 is -1. So we get -1 modulo 10. So what is -1 modulo 10? 9. So 17 power of 50, the last digit is 9. Now the next one, the last two digit. So the last two digit, the logic is that if the last digit using modulo 10, then the last two digit will using modulo 100. and so on and so forth. Let's say if we want to find the last three digit, then the logic is using modulo 1000. But since now the modulo is quite big, then the answer or the solution is not as easy as before. So the same logic here, we're using modulo 100 because the range of solution, if we are using modulo 100, is 0, 0, 0, 1, 0, 2 until 99. Okay, and then this one is the range of solution for the last two digit. So now here we can write it down as 17 power of 50 modulo 100. Now we are faced with difficulty here because now 17 is already smaller than 100. It means that we cannot simplify it anymore. So from here, now we will find the pattern of 17. So 17 power of 1 modulo 100 is 17. 17 power of 2 modulo 100 is, now I'm going to use calculator. Actually we have a better way how to solve this one, but for this moment I will just stick to the way we are solving this problem before. So, and then we can see the difficulties we face when we're using the same method with this kind of problems. So 17 power of 3 so I'll make it short. So based on my calculator, I got 17 power of 20 modulo 100 is 0, 1. We already found the weakness of this method because here I'm using calculator, but if you're calculating without calculator, it will take a lot of time. But let's proceed with this one. So we got 17 power of 20. So then we will solve 17 power of 50. Sorry, I will change 17 power of 50 becomes 17 power of 20, right? Power of 2 multiplied by 17 power of 10 modulo 100. So here 17 of power of 20 modulo 100 is 0, 1. Power of 2 times 17 power of 10 modulo 100. So 17, 0, 1, power of 2 is 1. So we will get 17 power of 10 modulo 100. And if you're calculating them one by one here, then of course you will find the 17 power of 10. So if you're using calculator, then we'll find the answer is, so the answer is 49. But for this reason, yeah, it's very difficult for using this one. So we're using another method that I will discuss later that make these things more simple. So to conclude all of that, we'll solve the last problem. So the last problem is find the last digit of 113, power of 113. So this one is same thing we will using, because the last digit, it means that we will using modulo 10. After using modulo 10, now we will simplify. 113 modulo 10 is 3, so we got 3 power of 113 modulo 10. So 3 here, I will make it quick by 3 power of 2. So here 113, I will divide it by 2, 12, and then 1. So it means that 3 power of 2 times 56 plus 1 modulo 10. So next, why I'm using 3 power of 2? Because 3 power of 2 is 9, and then 9 modulo 10 is minus 1, right? So we either using 1 or minus 1 if the power too big for us to calculate it one by one. So then I will get minus 1 power of 56 times 3 power of 1 modulo 10 minus 1 power of 56 is 1. So we got 3 modulo 10, and then 3 modulo 10 is 3. So 3 is the answer. So okay, so now the next one is that I have this one problem. What is remainder of 16 power of 2022 when divided by 35? So same thing. You cannot simplify 16 with 35 because 16 already smaller than 35. So it means that we will find the pattern of 16, which is quite difficult. For example, if the pattern is too big, like what we already experienced before. So to solve this one, I'll using Euler-Pi theorem. You can see the link below, and then you can check it how we solve this one, and then same thing with that modulo 100. So that's it for this video. Thank you.